Okay, so yesterday we started talking about lesson 2.8. I didn't get very far, right? But we started talking about lesson 2.8. So let me review kind of where we were at. We have this function. We're trying to determine the values of x, the real number values of x, that cause the function to be 0, positive, and negative. Now, we already talked about 0. 0 is old news. It's just like finding your zeros. Basically, where each of these parentheses equals 0. So x plus 3 equals 0 when x equals negative 3. X minus 4 equals 0 at x equals 4. And then I don't think I had written this in this class. I think I wrote this in my afternoon class. But I had someone question, well, how is this one not 1 or negative 1? If you take x squared plus 1 and set it equal to 0, subtract the 1 over, and then square root, what is the square root of negative 1? And that is I. So you'd have plus or minus I here, but we only want real number solutions. So that x squared plus 1 doesn't matter in this case. If it was x squared minus 1, that would matter. That would give you real values. But x squared plus 1 does not give you real values. So we talked about the places that make my graph 0 are x equals negative 3 and x equals 4. We did a little review. Remember multiplicities? Multiplicities come from our powers. So x equals negative 3 has a multiplicity of 1 because the power on that factor is 1. X equals 4 has a multiplicity of 2 because it's a power of 2 on that factor. And then we talked about what the multiplicity means and the fact that an odd multiplicity, a multiplicity of 1, says we're going to cross the x-axis. An even multiplicity, so multiplicity of 2, says it's going to touch the x-axis. Okay? And then I was getting ready to take you guys through B and C, and I said we're going to talk about using a sign chart, which in your homework, the directions I'm going to give you, remind me to make sure I clear this up with you, is that on 2 through 12 in homework, it's evens in that section, 2 through 12, I want you using a sign chart, kind of like what we're going to do here on example 1 and example 2. Okay, I want you guys using sign charts. The rest of them, you can use graphs, which I'll start showing you some graphs at example 3 and going forward. Okay? So, on this sign chart, what I said is we wanted to put our 0 values. Our 0 values were negative 3 and 4. I just have negative 3 and 4 kind of evenly spaced. I'm not worrying about spacing them appropriately with all the other numbers. Okay? And then what we want to look at is, okay, what's happening in each section? The section to the left of negative 3, is my graph positive or negative here? The section in between negative 3 and 4, is my graph positive or negative? And the section to the right of 4, is my graph positive or negative? At negative 3 and 4, it's 0. We know that. But what's happening in between each section? Is it positive or negative? Okay. If we were just looking at the graph, it's okay, is the graph positive above the x-axis? Or is it negative below the x-axis? But we're looking at analytically, algebraically, how can we do this? So, what I want you to do, to the left of negative 3, we need a test value. We need a value that we can test the situation with. And what value do you want to use in that section to test with? What's a number that's in this area?
Negative.
Okay. Negative 4 is what I would use, I'll be honest. Is that the number we have to use? Okay. You need to pick some number left of negative 3. Less than negative 3. Okay. I would pick negative 4 because I usually just go for the next number below. But you can pick any number there. If you listen to 5th hour video from yesterday, we had that discussion because, of course, I had Jaden picking negative 8. So, you know. Jaden had to be different, but the rest of us went with negative 4. But it all works the same. So, okay, so what we're going to do in this negative 4, all I care about is does negative 4 produce positive or negative factors. So we're going to take this negative 4, and we're going to plug it into our factored version of this. When I plug negative 4 in my first parentheses, what do you know about negative 4 plus 3? I don't care numerically what negative 4 plus 3 is, but what do you know about negative 4 plus 3? It's going to result in a negative. Okay. If you plugged any appropriate number in there, you're going to get a negative. Now put -4 in the middle parentheses. If I do -4 and square it and add 1, what am I going to get? I'm going to get a positive. And then if I put -4 in the last parenthesis, -4 minus 4 is going to result in a -4 minus 4 is a negative, but what's the catch here? It's squaring it, and what happens when you square a negative? It's a positive. So in this section, what is a negative times a positive times a positive? Negative. It is a negative. So this section of the graph will be negative. In other words, if you were to graph this on your calculator, the -3 is a place that it touches or crosses the x-axis. It's going to be negative there. It's going to be below the x-axis over in that area. Okay, now we're going to try the next section. So pick a value between -3 and 4. What's an easy value between -3 and 4 to test with? What'd you say? 1? I like even easier than 1. 0. And here's the deal. Doesn't matter. 0, 1. I don't know. Afternoon class yesterday said 1 also at first. To me, 0 is easier. I always pick 0 if I can. But pick a value in there between -3 and 4 and test it. So whether I use 0, Miles uses 1, whatever. 0 plus 3 results in a positive. 0 squared plus 1 results in a positive. And 0 minus 4, but then squared, results in a positive. What's a positive times a positive times a positive? A positive. Okay, and check the last piece. So now we need a value to the right of 4.
63.
I'm going to go with 5. You go with your 63. And here's the deal. It all works out the same. Okay? And you don't even necessarily have to write what value you're testing with. This is just me as a teacher trying to, give you notes yourself. So if I plug in 5, 63, whatever. What do we know about 5 plus 3? That is a positive. 5 squared plus 1? Positive. 5 minus 4, quantity squared? Positive. What's a positive times a positive times a positive? A positive. Okay. Now, think about it a little bit, and let's talk about why this makes sense. My graph goes from negative to positive to positive. Notice, what is my graph supposed to be doing at -3? It is crossing the x-axis. And then at 4, it is supposed to be touching the x-axis. Does that make sense? If my graph is negative over here to the left of -3, it crosses through the x-axis at -3, and now it is positive. And then what's it do at 4? It touches, and then it goes back up and stays positive. So does that all kind of make sense together? Okay. So this is a sign chart. When you're asked to analytically do something or use a sign chart, this is what I'm looking for. Now, officially, we still have to answer B and C. But we have the information. It's just a matter of writing the answer. So part B is what values of x cause the graph to be positive. What are my positive sections here? I'm positive from where to where? From -3 to 4. And I'm doing like interval notation. I'm using parentheses because is my graph positive at -3 and 4? No, my graph is equal to 0 at negative 3 and 4. So I have to use parentheses. So negative 3 to 4, it's positive. And where else is it positive? 4 to infinity. Good job. And again, using all parentheses because we're not being asked where it's equal to 0 right now. It was just when it's positive. So that's the positive answer. And then we have a question of what values of x cause my graph to be negative? Where's my graph negative? Negative infinity to negative 3. So that's over here.
And for our homework, you want us to use the sign chart for problems 2 through 12.
2 through 12.
2 through 12.
Yeah. And I will make sure, don't let me run out of time, I'll make sure I address that. But yeah, I have written that 2 through 12 we'll use sign charts, and then we'll graph the others. I just didn't have really room to write it in that box over there on the sideboard. And honestly, those directions might not have even made it in Skyward or on Schoology, so probably need to check that. Okay, questions on example 1. Okay, I'm going to move to a new screen for example 2 just so I have room. Notice example 2. It says solving the polynomial inequality analytically using algebra. This is the type of stuff I'm going to be looking for on 2 through 12. Okay? Notice when we get to example 3, it says graphically. So we'll talk about how to use the calculator to do it instead, which is the easier stuff. But now, what's different between the example 1 equation and this example 2 equation? Example 1 was factored. Example 2, not factored. Sorry, I said it. I'm going to write it. Analytically means I want to see a sign chart here. So, here's the deal, guys. In order to do this one analytically, we have to factor it. In order to factor it, this comes down to our rational root theorems like the PRRs and the synthetic division. Okay? Now, in the end, when we solve this, it says, remember, if f of x is greater than 0, we're looking for where the graph is positive. And that's because it says greater than 0. That's why we're looking for where the graph is positive. If it said less than 0, we'd be looking for where the graph is negative. Okay? So, let's talk a little bit about PRRs. Review PRRs a little bit. What do you remember about PRRs? We're going to be doing factors of 24 over factors of 2. Because it's factors of the constant over factors of the lead coefficient. Okay, what are factors of 24? 1, 2, 3, 4, 6, 8, 12, and 24. All over factors of 2, which are 1 and 2. And I did fail to mention I was putting plus or minus in front of all those, right?
I just put the plus or minus in the beginning because it's annoying.
Okay. And here's what I'll say, guys. Yes, PRRs should be thought of your thought process here. Am I grading PRRs, though? I mean, I'm glancing at them to make sure that you attempted the process, but you could go through it and write those all out. I'm trying to look, yeah, I didn't even do that in my notes. What I do now is, okay, I can kind of see 1, 2, 3, 4, 6, 8, 12, 24, and then all of those divided by 2, right? I can kind of note that in my head, but what do we usually do? Do we start trying all of these? No. We look now and see, what does the graph suggest? Okay, now, looking to see what the graph suggests is kind of a shortcut, kind of cheating in a way, you know, if you want to go there, but it's what helps us to be able to do this. So, grab your calculator and get this graphed. So I'm graphing 2x to the third minus 7x squared minus 10x plus 24. Okay. I've got mine graphed. You getting yours graph? What suggestions is that graph suggesting? What do you think, Natalie?
-2, positive 3 halves, and positive 4.
Okay. And I will say 3 halves question mark. I mean, the thing is, irrationals have to occur in pairs. So -2 and 4 are pretty obvious. That means that other one has to be a rational option. And considering 3 halves is an option, it's probably 3 halves is our third. Yes?
So I put mine in right, but it's not graphing right. Oh, I see. Never mind.
Glad I could help.
You help.
Okay. Just glad I could help there.
Moral support.
Yeah.
Okay, that's good.
You figured it out then?
I forgot the X on the 10.
So you thought you had it plugged in right? Because that was going to be, even though you're telling me you have it plugged in right, that's still going to be the first thing I check is I visually want to see that you have it plugged in right. Okay, so how do these PRRs and the graph suggesting these values, how do they help me factor this? We start with synthetic division, right? I'm going to use my -2 and my 4 first. I'm going to save my 3 halves for last because by that point I'll just be able to confirm it. So if I put -2 in my box, and then 2, -7, -10, and 24. Drop the 2, multiply. -2 times 2 is -4. Add, -7 and -4 is -11. Multiply, -2 and -11, 22. Add, -10 plus 22 is 12. Multiply, -2 times 12, -24. Add, and we get 0. So what do we know? 0 is a good thing. -2 works. If -2 works, what factor does that represent? We know one of our factors is x plus 2, right? Because that's what we're trying to do, is we're trying to factor this all down. And we know one of our factors is going to be x minus -2, which is x plus 2. Now what? Now we're going to try 4. What's the trick with 4? Yeah, we're going to use our new set of numbers. So I'm going to use 2, -11, and 12. Drop the 2. 4 times 2 is 8. -11 plus 8 is -3. 4 times -3 is -12. 12 plus -12 is 0. So, remainder of 0. That means 4 works. And 4 represents what factor? X minus 4. So the 0 of 4 represents a factor of x minus 4. you know what? If I scoot that over, I'm going to scoot that over just a little bit, sorry. Now, we have an option here. We have one more to try, right? The one to try is the 3/2. However, we also have that information right here. You wouldn't even have to try it at this point because what do you know about this 2, -3? This would be 2x minus 3. And what happens when you solve that? You get x equals 3/2. So what is our other factor then? It's the 2x minus 3. You don't want to say x minus 3/2. I guess you could, but we traditionally don't say x minus 3/2. We say the 2x minus 3. Okay, so what I want you to realize, our original function, I'm going to write it out here. Our original function was 2x cubed minus 7x squared minus 10x plus 24. What synthetic division allowed me to do is it allowed me to factor that. What did I factor it into? I factored into x plus 2. I factored it into x minus 4 and the 2x minus 3. And the whole point of factoring this is what I can use with my sign chart now. Okay? That's why when we go and plug in numbers, we can plug in numbers like to each factor and figure out whether each factor is positive or negative. Okay? So yeah, some of them, they require a little bit more work. Let's set up our sign chart now. Sign chart, which I expect to see on 2 through 12, is your big old number line, right? So when I say use a sign chart, this is what I'm expecting. And I'm even labeling it so you know what I'm meaning by sign chart here. What values do I need to put on my sign chart? Well, what values came from each factor, right? So this is your zeros. So I'm going to have -2 on here. I'm going to have 3/2. And I'm going to have 4. Notice I didn't worry about spacing them out appropriately, but I put them in order from least to greatest. They need to be in numerical order, but they don't have to be spaced appropriately, if that makes sense. Okay. So, you ready to test them? And where are we going to test them? We're going to test them in here. Okay, we're going to test them in those 3 factors. Now, to the left of -2, pick a number. What number do you want to test with? I'd pick -3. You can pick any number left of -3, yes? Do I need to write that down? You do not have to write the number that you're testing with down, but I'm just for the minute. So if I put -3 in, what do we know about -3 plus 2? -3 plus 2 is going to be a negative. What about -3 minus 4? -3 minus 4 is going to be a negative. What about 2 times -3 minus 3? That's a negative. What's a negative times a negative times a negative?
Oh, sorry. I was like,
3 negatives multiplies to be a negative.
I was thinking a little too hard.
Okay. Odd number of negatives multiplies to be a negative, though, yes? Oh, trust me, homeroom we experienced. We are full of math mistakes today. Something about today, I don't know. Okay, what about negative 2 to 3 halves? Pick a value that's in there. I personally would use 0. And again, you don't have to tell me what value you're testing with, but put in 0. 0 plus 2 is going to be a positive. 0 minus 4 is a negative. 2 times 0 minus 3 is a negative. Positive times negative results in a positive. Three halves to 4. I would do 2. I mean, your basic options are 2 or 3 unless you want to get fancy with a fraction. So let's see, 2 plus 2, when I put it in my first factor, is a positive. 2 minus 4 is a negative. 2 times 2 minus 3 is a positive. What's a positive times a negative times a positive? A negative. And a value bigger than 4. I'm going 5. You going 63 again, Jacob?
Yeah.
Okay. So 5 plus 2 is a positive. 5 minus 4 is a positive. 2 times 5 minus 3 is a positive. And I know a positive times a positive times a positive is a positive. I don't need any help making math mistakes. I really don't.
He's thinking a little too
No, that one was done on purpose. He had a smile on his face with that one. Okay. Now, we have to answer our question. And at this point, you say, what the heck was the question?
Yeah.
Okay.
Yeah.
The question was, solve this equation greater than 0. What does greater than 0 mean? Greater than 0 means positive. So our question was greater than 0. So I want to know, when is my graph positive? So in what intervals is my graph positive?
Between
Negative 2 to 3 halves. And, so union, where else is it positive? 4 to infinity. Okay. Yes, I know there's a decent amount of work there. I get it. Okay. But this is your process when it's not a, not a calculator type problem.
it's really not that bad. It's just not that hard.
Yeah. And here's the deal. We did PRRs not last chapter, but a couple lessons ago. We did the synthetic division with it. So we've done that factoring stuff. So all it is we're doing the factoring and then we're adding the sign chart. Okay?
So when it's facing that way, you're only answering when it's positive.
Right. So this is a greater than sign. Greater than 0, we want to know when it's positive. If it said less than 0, we'd want to know when the graph is negative. You'd be giving me your negative intervals.
And if it wants both, it'll just ask for both.
Yeah. If I think, is it maybe the first 2 problems are kind of like example 1 where they want zeros, positive and negative? Okay. Does that sound right?
First 2.
First 3. So 2, 4, and 6, you're doing like example 1. Then I'm guessing 8, 10, and 12, you're doing like this. And then after that, we're going to talk example 3.
14 to 20.
Does it say something about graphing?
Yeah, inequality.
Okay. So, moving along. That makes sure we get a little bit of examples in here. Example 3, solve a polynomial inequality graphically. And notice it does say review here. So, get technical. We've done this. But we're looking graphically. Now, as we look at x cubed minus 6x squared less than or equal to 2 minus 8x, what are we going to have to do first? Can't graph it quite yet. Why can I not graph it yet? It's not equal to 0. Or in this case, less than or equal to 0. So if you will, please, rearrange your equation. I'm going to subtract 2 and add 8x over to the left. And then when I do that, I'm going to have x cubed minus 6x squared plus 8x minus 2 is less than or equal to 0. If it's not in a form that has 0 on one side, you need to start there. We need to get it with 0 on one side. So, since the question says less than or equal to 0, what does that mean? I want to know, where is the graph negative? That is the question we are answering, is where's the graph negative? Now, what does that mean? Since we're doing this problem graphically, you don't have to do a sign chart. And in fact, honestly, there's a good chance this problem doesn't factor. Thus the reason we have to do it graphically, because it doesn't factor. So if it doesn't factor, we're going to graph it. If we're looking for where this graph is negative, where is that on the graph? That means we're going to be looking for where our graph is, where in relation to the x-axis. Negative means below the x-axis. Now, what is that less than or equal to? What tweak does that throw in there? We're not just going to look for below, we're going to look for on or below the x-axis. Okay? That's what we're trying to figure out. So, first thing you are doing now is you are graphing. I'm going to write the information here, but you need to graph. You're going to graph y equals the x cubed minus 6x squared plus 8x minus 2. And then what are you going to have to know? We're going to have to find the zeros. Okay. So let me get mine graphed. Okay. I see on my graph 3 x-intercepts, yes? We need to specifically know each and every one of those values. Okay, so I know it takes a bit of time, but yes, I need you to find those zeros. Use your calculator. Yes, they are going to be decimals.
When we do it graphically, do you want us to draw the graph too?
You don't necessarily have to. This, of course, is more of a notes thing. The visual, you go back and look at your notes later, you can figure out what we were talking about, but I don't necessarily have to have the graph, if that makes sense. Okay, did you find some zeros? Remember, you're doing your second calc 0, left bound, right bound, and a guess. Remember how to do those? Okay. I know, I do mine a little bit fast. So I have mine to 2 decimal places. So I have this first one as 0.32. Do you guys have the others? $1.46. And then I have 4.21. Are those matching with what you guys are finding as you're finding them? And by all means, you know, if you're not getting those zeros, double check that you have the equation typed in right, not wrong, and then double check with me and I'll help you figure out what's going wrong, okay? Now, okay, I'm ready to answer my question. This one goes a lot quicker because we don't have to go through all the factoring. When is this equation less than or equal to 0? So when is this equation less than or equal to 0? So that means I'm asking, where is this graph? Below the x-axis. We have one section there that's below the x-axis, and we have a second section that's below the x-axis, right? So your answer is the interval of x values that includes. Am I making sense? We've done something similar to this. Okay, so as we approach 0.32, those x values are negative, or those y values are negative, right? So how do I express that? Negative infinity to positive 0.32. Now, parentheses or bracket? What? Bracket. Bracket this time because it said less than or equal to. If it just says less than or greater than, parentheses. If it says less than or equal to, or greater than or equal to, brackets. Okay, union. Where else is my graph negative? Between the x values of 1.46 to 4.21. What am I going to use on either end of those? Brackets again. Okay. Where are we at on time? Okay. Now, I am going to say, yes, I know there's a lot of examples of graphs and we haven't had a chance to get to them. However, yes, I'm still going to have homework due tomorrow. Okay. All of the rest of these are just graphs and some special cases and those kind of things. And we will very possibly have to, talk about some of them tomorrow. But I do want you to attempt these for homework. Okay. On your homework. Okay, I'm going to go ahead and list it here while I'm thinking about it. And if we get a chance to talk about the next one, I will, but I know I'm running out of time. Page 242, and it's 2 through 20 evens, and Al said the wrong number. 34 to 44 evens. As I mentioned earlier, I'm going to put it in writing here. 2 through 12, I am asking you to do a sign chart. And the directions are asking you to do a sign chart. All others, what do you get to do with all others? You get to graph. Does that make sense there? Okay, so 2 through 12, you're going to tackle those sign charts. Some of them you're going to have to factor. Some of them are already going to be factored for you. And then the rest are graphs. So you don't have to do the sign charts. You don't have to You don't do anything fancier. So yeah, 2, 4, 6 is like number 1. 8, 10, 12 is like example 2. The rest are variations on graphing. Okay? Yeah, okay, so be aware. 34 to 44 says using a sign chart. I'm telling you no, I'm telling you to graph. Okay? Questions for me? Okay. I will say, like, when you get to the back side, you will have to think about, I'll just kind of mention this real quick, but, like, for instance, this one would have some vertical asymptotes. Okay? And so you're going to have to watch, this is where you use the equation and the graph together, because this one, you would end up with asymptotes at x equals -3 and x equals 1, and that would make a difference there, okay? Give it a try, bring it tomorrow, we'll talk questions, but homework is due tomorrow.